This is going to be a short recording on logical ANDing. There was a mention of this in the bottom of that worksheet that you guys were supposed to be working on, the one with decimal and binary conversions. And down in the bottom it mentions logical ANDing, but I didn't really ask you guys to do anything with that. But somebody was asking, a couple of people actually, were asking about how logical ANDing works, so I thought I would try to do this little explanation. Okay, now this is how computers see networks and network addresses. Obviously, whenever we're looking at a network, we can just kind of eyeball it, and we can see that if we have a subnet mask of 255.255.255.0, and we have a host address of 192.168.10.1, we just kind of intuitively know that, okay, well, these are all ones, and so the first three octets are the network address. So in this case, the network would be 192.168.10.1. But computers don't think that way. Computers use binary. Everything to a computer is a 1 or a 0. Whether you're talking about a document or a picture, it doesn't really matter. Everything is encoded, which is called digitizing. So we convert pictures, videos, everything into ones and zeros with an analog to digital converter. And then when the computer looks at it, it just sees ones and zeros, but it knows how to translate that back into something that we can understand, which is how it displays things on your monitor. Now, when computers are trying to determine which network and which host address they're supposed to be using, this is how they do it. Now, logical ANDing. With a logical AND, a 1 and a 1 gives you a 1. A 1 and a 0 gives you a 0. So in order for there to be a 1 in the network address, which is what we're going to be looking for here, there have to be two ones, otherwise it's a 0. Okay, so if we're looking for the network address, and this is how the computer does it, but computers do things way faster than we can. Okay, so 1 and 1 is 1, 1 and 1 is 1, 1 and 0 is 0, and so we see that we've got all zeros here, so everything in this octet remaining is going to be a 0. Okay, now once again, we've got 1 and 1, we've got 1 and 0, 1 and 1, 1 and 0, 1 and 1, 1 and 0, 0, 0. Okay, now we've got a bunch of zeros here, so we know those are all going to be zeros. We've got a 1 and a 1, which is a 1. 1 and a 0 is a 0. 1 and 1 is 1. Whoops. A 1 and 0 is 0. And then down here at the last part of the subnet, everything is a 0. See, this is 255.255.255.0, so these are all zeros. Okay, so if we're looking at this, we can see that in the computer's parlance, our network address is going to be 192.168.10.0. Okay, so that's the network that this machine belongs to. Now, if we want to determine, say we've got another host address, and the computer wonders, okay, well, is this host address on the same network as this first host was, 192.168.10.1? Well, here is the host address written out in binary, 11000, okay, 192.168.12.12. Okay, so we're going to do our logical ANDing. Remember, this is our network address, so we can either use this or we can use this host address. Either way, you know, as long as we're true to the subnet mask, this will work out for us. So if we look and we see 1 and 1, okay, let me get another line going here. 1 and 1 is 1, 1, 0, 0, 0, 0, 0, 0, dot. Okay, 1 and 1, zeros, 1 and 1, zeros, 1 and 1, 0, 0, 0, dot. Okay, now we got zeros, we got 1 and 1, Okay, now we've got a 1 here, but in these addresses, we've got zeros. So that's a 0. Okay, and then we got 0, 0, dot. And then we know from looking at our address above and this address here, looks like we don't have any matches. Whoops. Okay, so the host address 192.168.12.12, is it on the same network as 192.168.10.1? Okay, well, we figured out that our network address was 192.168.10.0. So we can just kind of look and say, oh, okay, well, there's a 12 right there in the third octet, so obviously these are not in the same network. But the way the computer has to look at it is by looking down here. And it says, okay, these addresses are not in the same network because the third octet here is going to be different. Okay, so these network addresses are in 2 different networks, and so therefore they're going to have to communicate with a router. Okay, so in a nutshell, that basically is how logical ANDing works. It's not something that we have to really worry about that much as human beings, but this is how the computer determines if 2 hosts are on the same network, or if one host and if you've got a host address and a network address, are those on the same network? Either way works. So anyways, that basically in a nutshell is logical ANDing, and hopefully this helps a little bit. I don't know if it will or not, but thanks for listening anyway, and I'll see you in the next one.